10.5, which introduces the concept of the standard deviation. So in prior sections, we learned about measures of center, which provide a single number to describe the center or the average of a data set. And so some of the examples we learned about were the mean, the median, and the mode. And so let's take a look at two data sets. And let's calculate the mean for each data set. So the mean of the first data set is 18, and the mean of the second data set is also 18. But when we look at the data sets, we notice that they're very different. In the second data set, all the data values are the same. In the first data set, we notice that there's a difference among the data values. They're all different, and the smallest is 12, the largest is 24. So the mean alone doesn't explain the differences between the two data sets. We'd like to come up with some other measures that would explain differences between or among data sets. And those are called measures of variation. And these describe the spread or the variation in a data set. How different are the data values from one another? And one measure of variation is called the range, which is simply the distance from the smallest to the largest. So again, going back to those two data sets, we could calculate the range for each. The range for the first one is 12. The range for the second one is 0. So now with the mean and the range, I know more about each data set. I know that the second data set, because the range is 0, all the data values are the same. There is no variation from one another. They're all exactly the same. So we know the mean is 18. We know the mean doesn't show the variation that's occurring, so we're going to use the range. But the range only uses 2 of the data values, so we've thrown away the rest of the data values. We'd like to have a measure of variation that uses all the data values. So again, going back to that data set, we're going to look at how far each of the data values is from the mean. And in order to do that, we're going to go ahead and calculate the difference between the data value and the mean in the first column, and then we're going to square that difference. So in the first cell there, if I take 12 minus 18, I get -6, and when I square it, I get 36. I'm going to do the same thing down in the remaining rows there. 15 minus 18 is -3, and so forth, and then I'm going to square those data values in the last column. Now, one thing I want to point out is if you look at the second column, if you sum up these numbers here, which is just the difference between each data value and the mean, you get 0. So that's not very helpful in terms of variation, because for any data set, if you do this calculation, you're always going to get a sum of 0. But when we square the deviations, we won't get a sum of 0 unless the data values are all the same. So the next step we're going to do, and this is what we call the deviations from the mean in the second column. So how far is each data value? What's the distance from the mean? Notice some of those deviations are positive and negative, and that they will always sum up to 0. So that doesn't help us. So we're going to square the deviations. Now all the numbers are 0 or positive. And when we add these up, we get 90. So the next calculation we're going to do is we're going to divide the squared deviations. We got 90. We added them. Then we're going to divide by the mean. We're going to divide by the number of data values to get the mean of the squared deviations. In this case, it's 18. And then we're going to take the square root. So in order for the square deviations, these are not in the original units, so we take the square root to get back to the original units. For this problem, it's around 4.24. And this is what we call the standard deviation of the data set. And on page 294 in your book is a picture, a little block that shows you how it works. I'm going to recommend that you always use the table approach that I just showed you because it makes it really easy to do the calculations.